what are we talking about when we say routing protocols? Routing protocols are the protocols of routers. Okay, so what we mean is routers talking to routers on the network, talking with each other, sharing routes and routing information with each other. Now, routing protocols are different than, let's say, a routed protocol. A routed protocol would be something like IP, Internet Protocol. TCP/IP is a routable protocol, a routed protocol. A routing protocol is different. A routing protocol is a protocol used by a router. So here's two types. We've got IGP and EGP, or interior gateway protocols and exterior gateway protocols. Okay, quite simply, interior gateway protocols are routing protocols such as RIP, RIP version 2, IGRP, EIGRP, OSPF, and ISIS or ISIS. In the Cisco CCNA, you're required to know how to configure RIP, RIP version 2, EIGRP, and OSPF. You used to be able to have to know IGRP also, but IGRP has been succeeded by EIGRP, and IGRP is no longer being taught. It's kind of a ISIS is CCNP material, and then BGP, an exterior gateway protocol, is also CCNP material. The border gateway protocol, this one right here, is used for going from usually ISPs to ISPs, or from autonomous systems to ISPs, and once again, that's CCNP stuff. But you need to know what it is, the two different types, interior gateway protocol and exterior gateway protocols. Okay, so we're going to mostly be talking in the Cisco CCNA about interior gateway protocols. We're talking about two types, distance vector and link state protocols. All right? Okay, distance vector protocols are protocols such as RIP, RIP version 2, IGRP, and EIGRP, EIGRP. IGRP and EIGRP are both Cisco proprietary protocols written by Cisco. And RIP and RIP version 2, RIP is the oldest routing protocol out there. It's quite old and it's a little bit outdated, but we still learn it in the Cisco curriculum. And then link state protocols, I've got here OSPF, Open Shortest Path First, and ISIS, and you have to know how to configure OSPF in the Cisco CCNA. So let's talk about some of the differences between distance vector and link state protocols. Okay, in distance vector protocols, routers communicate with neighboring routers, advertising networks, as measures of distance and vector. Okay, so so the thing to remember there is routers are communicating with neighbor routers, right? As opposed to link state, where routers communicate with all other routers, exchanging link state information to build a topology of the entire network. In a link state, routers communicate with all other routers. Distance vector, routers are communicating with neighbor routers. And let's go to the next row here. So measures of distance and vector. Well, in distance vector, distance refers to the metric. So the distance, like in RIP, would be hop count. So how many hops or how many routers to get to a network. How many routers do you have to pass to get to a network, or how many hops do you have to get to? That would be the distance, which is also known as the metric. And then vector means direction, which in this case with routers would be which interface are you going to go out of. Okay, and with link state, the words link state refer to the interfaces on the routers, or the links to other routers and other networks. So when you talk about a link state, we're talking about the state of the link or connection to another network. And those, of course, you know, the links can go up or down. All right. Distance vector, what's it best for? Distance vector is best for simple networks of a flat design, non-hierarchical networks like hub and spoke networks. Also, it's best for, they're a little bit simpler, distance vector, so you need minimum administrator knowledge to configure them. And they don't converge as fast as link state routing protocols, so it's good for a network where convergence time is not an issue. Okay, and I'll talk about what does that mean, convergence time. So on the opposite side, link state is best for larger networks that have a hierarchical design. Hierarchical networks, you need more advanced administrator knowledge. For instance, OSPF is a complex routing protocol. I've got a huge book over there all about OSPF, and it's also a CCNP topic that you can go very deep into and can be a complex routing protocol. So you need advanced administrator knowledge, and it's best if if convergence time is an issue, right? If you want your networks to converge and they need to figure out, the routers need to figure out about the network quickly, then you might be best to go with a link state protocol. Now, what is convergence? Convergence, when we're talking about routers, means that all the routers in the network have the same picture of the network. So let's say you have 3 routers in the network and one of the networks goes down. One of the links goes down. All right, when that link goes down, if all the routers no longer know about that network being down, then the network has not converged. Okay, once all of the routers have learned that the network is gone and that the network has gone down and the link's gone, then the network has converged. So converged network means that all the routers have the same information and know when a network is up or down. Okay, and how do they learn that? They learn that by communicating with each other. So when a network goes down, the routers need to communicate with each other and let them know that, hey, this network is down. And once everybody knows, then the network has converged. Okay, so on the next row here, I've got with distance vector, knowledge of the network from directly connected neighbors. So with a distance vector routing protocol, routers can build an entire picture of the network through directly connected neighbors. So we learn about other networks and the distances to other networks, and so eventually we can learn about all the networks in the all of the available networks in our system, right, by communicating from router to router about the different networks that each router has. But in a link state routing protocol, the routers don't just know from router to router. Routers have a complete view of the network. They have the knowledge of all of the links that all of the routers have, and so they have knowledge of the entire topology, and then they can build the best path to a route, or the best path and a route to a network based on information of all of the routers. So they have knowledge of complete view of the network, and these are key terms. So if the question on, if you're trying to get your CCNA and trying to do the CCNA exam, and the question says, you know, which routing protocol builds a complete view of the network, well, that's going to be link state, right? If you have build an entire topology of the network, that's link state, right? Knowledge only from directly connected neighbors, that's distance vector. Okay, distance vector routing protocols send periodic updates of the entire routing table, oftentimes. So, for instance, with RIP, every 30 seconds, RIP sends out its entire routing table to its directly connected neighbors, right? So every 30 seconds, RIP sends out entire routing table, right? With link state routing protocols, they send triggered updates and partial updates. So they send oftentimes only the information that you need and only when a network goes down. So that's what I mean by triggered and then partial. It's just the information that you need about a particular network going down or a particular link going down, and that's sent on a triggered state.